Okay, 8.1, similar polygons. So starting off, I'm not really sure what I meant whenever I wrote that, so you don't really need to copy that down. But let's start off right here where I say that triangle ABC is similar to triangle DEF. And that squiggly line means is similar to, right? We've got some different symbols. We have the equal sign, we have the congruent sign, we have the similar to sign. And I think there's more, but those are the three that I can remember right now. If we start off with triangle ABC, the blue triangle on the left here, and then we have a similarity transformation, that could be like a dilation. Remember dilations, where we make it bigger or smaller. And it turns into triangle DEF. Notice that the angles, the corresponding angles are congruent. And then each of the sides, let's look there. Here we have A, here we have KA. So there's a dilation and it multiplied it by something, okay? Our dilation factor or our scale factor here would be K. Notice how it has the similarity transformation, it has an arrow pointing to the right. Okay, that means that we went from the small one to the big one. That's what that's meaning. If a problem does not have the arrow, then you can make the decision on, am I going to the small one to the big one or the big one to the small one, right? If it was something like you're going from the big one to the small one, then we would say the scale factor would be like 1 over k, right? Because you would be dividing by k to get the smaller one, okay? So you can think about it either way. Corresponding angles. I think I already talked about that. Each of the angles has a partner and they are congruent. For the sides, they're all listed as like a ratio. So we have DE, which is this here, over AB, and then EF over BC, and FD over CA. So each time, each of those would be equal to K, right? Because this would be, for DE, it is KC, and then AB is just a plain old C, right? So you cancel the C's out and you're left with K. That's what that's saying. Notice that the red triangle, the right triangle, the bigger one, is all in the numerator. And the smaller one, the blue triangle, is all in the denominator, okay? That matters. If you start off with one of them in the numerator, you have to keep them all in the numerator, right? I'm talking about these right here. All right, let's look at some examples. Number one, triangle RST. And whenever I type this up, you can, or I always use like the words, but you can use the symbols whenever you take notes. So this is triangle RST is similar to triangle XYZ. Starting off, find the scale factor. Well, I'm going to pick a side. I'll pick RS and XY. Now, hopefully we can remember that whenever we have a similarity statement, the order that they're listed in matters, right? So R and S are in the first spot. X and Y are in the first two spots. So that's telling me that RS and XY, those sides go together. Now for the scale factor, I told you earlier that you have to decide which direction is the similarity transformation going in. I'm going to say that it's going from left to right, okay? If I say that it is going from left to right, then I need to take, well, what am I going to take? I'm going to take the 12 over 20. That will reduce to be what? 6 over 10, which is 3 over 5. That would be my K. Now, if instead I said that we went from right to left, and we did this piece here, then it would end up being 5/3 equals K. Okay? You have to make that decision for yourself. Which direction are we going in? Okay? On your homework or whatnot, you might want to write down, I'm going from the big triangle to the smaller one. All right. If you don't write that down, I will accept either of these answers just because I understand what you're doing. But it's a good thing to write that down. It's a good thing to know what's happening. Are we going from the big one to the small one or the small one to the big one? All right. So that's the scale factor. Lists all pairs of congruent angles. Now for this, we can either look at the picture or the similarity statement. I'm going to look at the similarity statement. And I already said it a little bit, but the first spot and the first spot goes together. So I can say angle R is congruent to angle X. Next up, the two middle spots will be angle S is congruent to angle Y. And the very last one is angle T is congruent to angle Z. Now we can look at the picture when we do that, and that's okay. But sometimes it's just easier to grab it from the similarity statement. All right, number 2, triangle GHJ is similar to triangle MKL. And again, whenever you're taking notes, you can write this as triangle GHJ similar to triangle MKL. So to find X, what I'm going to do here is, let me scroll up for a second. I'm going to do something along the lines of this, where I make a proportion. So I'm going to start off with my X, because my X is the one that matters. X is on KL, and I need to find the other side of the other triangle that corresponds to it. So KL is in the last two spots, so it's going to be HJ. So that's going to be X over 12. Right? Sometimes the pictures are nicely oriented to where we can tell obviously, right? If we're looking at these pictures, and I'm just looking right here, I could have probably told you that X and the 12 go together. But we always want to look at this similarity statement because sometimes the problems will flip the triangle over or something like that, and it's not so obvious. Okay, so always try to look at that similarity statement. Next up, we can just pick either of the two other sides. I'm going to pick the 15. That is MK, the first two spots, so GH is 10. Notice that in the numerator, I put the X and the 15. The X and the 15 came from the same triangle, right? The same triangle has to be on top, and the other triangle has to be on bottom. The rest of this problem is just solving. 15 over 10, I'll go ahead and reduce that. So I got X over 12 is, what is that, 3/2. Whenever I multiply by 12, I'll have X equals 3 times 12 over 2, which is the same thing as 3 times 6, which is 18. All right. Next up, Theorem 8.2, areas of similar polygons. If two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. All right, so what does that actually mean? Whenever I do these, I always try to remember what kind of units would I use. So I'd have inches for like length, inches squared for area, and this also works for volume. Inches cubed would be for volume, right? If I have a scale factor of like A over B in my inches, then for inches squared, it's going to be A over B squared. And then for volume, it would be A over B cubed. So what this is telling me is if I'm going from a triangle that has a side of 1, and then maybe it's going to a side of, I don't know, 5. So the similarity transformation increased it by 5, right? Our scale factor is 5. So for inches, that's just a plain old 5. Whenever I go to inches squared, it's 5 squared, or 25, right? And what I'm saying there is that as far as length goes, and this includes perimeter, anytime you're dealing with length with these two triangles, the bigger one is 5 times larger than the smaller one. Whenever we're talking about areas, the larger triangle is 25 times larger than the smaller triangle. And if we were talking about a 3D figure with volume, then it would be 5 cubed, which is 125. So if you have two figures that are similar 3D shapes, and their scale factor is 5, then their volume scale factor is 125. So let's see if we can apply that a little bit. Number 3, triangle ABC is similar to triangle DEF. Find the area of triangle DEF. All right, so this side and this side correspond, and we're supposed to find the area. We'll say area is x. Starting off, I want to find my scale factor. I'm going to go from the top one to the bottom one. Okay. The top one is 10, the bottom one is 5. So right there, what I did is I multiplied by 1/2. So K is 1/2, right? This is measured in inches. Or I guess here it's measured in centimeters, right? Centimeters. Now I want to talk about area. Area is measured in centimeters squared. So that means I need to square my scale factor. So this is 1/2 squared, which is 1/4. All right. Again, what I'm doing here is I'm going from the top triangle, the big one, to the small triangle, the bottom one. So I'm going to multiply 36 by 1/4. And that's going to be my area. 36 divided by 4. Is that 9? I think it is. 36 divided by 4 is 9. Yes. 9 equals x. And I could say, well, this is 9 centimeters squared. Okay. So that is that. Again, we don't need this volume piece that I put in here, but it does work, and eventually we will end up talking about that. One of the things that I highly suggest you do is to draw this arrow from one to the other. I think that's helpful. I think that's useful to remind you which direction are you going, all right? So good luck on the homework, and let me know if you need any help.